Namaste everyone. Today we will discuss about force and laws of motion, which is chapter 9 from ninth standard physics. So it's chapter 9, force and laws of motion. The previous chapter is motion. So both force and motion are branches of physics which we call them as mechanics. So mechanics particularly is a branch of physics which deals with the motion. In that mechanics, the chapter 8 motion is completely about the kinematics. So that branch which deals with motion irrespective of the forces acting on the object is kinematics. And then this concept, that is, this is also a chapter related to motion, but here we are more concentrating on the cause of motion. So this branch of physics is called dynamics. So dynamics is a branch of physics which deals with the causes responsible for the object to be in motion. So in the previous classes you have been learning about force. So to define force, we say it is a push or a pull acting on a body. So push or a pull experienced by a body, or force can be felt or experienced. It's an effect. So force causes some 4 to 5 effects acting on body depending on the shape of the body, depending on the mass of the body, and depending on its state of motion. So I'll write the 4 effects, major effects which the force can cause. So the first one, force can change the state of motion of a body. Force can change the state of motion of a body. State of motion. State of motion in the sense, if a body is at rest, the force makes the body to move. Or if a body is in motion, acting, the force can bring the body to rest. So just like when you are riding a bicycle starting from home, so you apply force. Actually the bicycle will be at rest and you push the pedals so that there is a change of state from rest to motion. And in vice versa, when you apply brakes, so brakes when you apply, so the moving bicycle comes to rest. This is done by the force. So force can make either changes. So it can bring a body to motion, at the same time it can stop a moving body. The second effect which force can produce is can change the direction of motion. Force acting on a body can change the direction of motion. So here the direction of motion, we can see this generally in games. So in games, while playing, the players, either it is a cricket or a football, whatever it may be, so the direction of ball is changed with the help of a bat in cricket, and in football the players will play in such a way that the direction of the ball is always changed so that it does not go under the control of the players of the opposite team. So then another effect of force is change in speed. So change in speed. The force acting on a body can increase or decrease the speed of the moving object. So it can either accelerate or retard the speed of a moving body. Then the last one which we can say is force can change the shape of the body. So this we will see when we apply force on a sponge or a spring. So these the change of the shape, that means that there will be a change of shape of an object when we are applying force. So these are the effects which are caused by force acting on a body. So balanced and unbalanced forces. Balanced. So what are balanced forces? So when a number of forces acting on a body, so when a number of forces acting on a body does not bring about any change in its state of rest or of uniform motion, something like the algebraic sum of all the forces acting on a body. So you can say, since force is a vector, so we use the term vector sum of all the forces. acting on a body is equal to 0, or we can say that the resultant of all the forces F1 plus F2 plus F3 plus F4. So the resultant sum of all the forces acting on a body is equal to 0. Then the body is said to be under the influence of balanced forces. So if balanced forces are acting on a body, then there will not be any change in its state of motion. So when I say there is no change in state of motion, means if the body is at rest, it will remain at rest. If it is in uniform motion along a straight line, then the body will continue to be in the uniform motion along the straight line. That is about the balanced forces. So unbalanced forces. Unbalanced forces are those forces which we are going to concentrate more upon, because unbalanced forces acting on a body definitely can bring about a change in the state of a body. Let us take that force F1 is greater than the force F2, such that the resultant force acting on the body is equal to the greater force minus the smaller force which is acting in the opposite direction. So which indicates that this body is moving in forward direction along the force F1 with the resultant force F, which is equal to the, we can see this F2, F1 minus F2. So unbalanced forces acting on a body definitely bring about a change in its state of motion. So our concentration for this chapter will be particularly on unbalanced forces. So to understand more about the motion and force, the relation between them, so we know that when you start from home on your bicycle, you need to continuously pedal the bicycle. So there is a continuous pedaling in order to make the bicycle move. And when you stop pedaling, so once you stop, what happens? Once you stop, even the bicycle stops. That means if an object has to move, there should be continuous supply of some force. Just like when the vehicles, so when the fuel continuously burns, so because of which the piston pushes the vehicle continuously. So we all have the notation that we are in an intuition that force is for a body to move continuously, there should be a force acting on it. A continuous force should be acting on it to make it move. The same idea was believed by Aristotle, the great philosopher, the Greek philosopher. So which he has given a theory that like he has given his idea, he has shared his idea that rest is a natural state. For any object, rest is the natural state. And if you want an object to move, then you need to continuously apply force on it. Just like at that time they may be watching the the carts which are pulled by the horses and donkeys. I mean, maybe different means of transport which is pulled by the animals. So that they have seen that only when the animal pulls, then the cart moves. So from that idea he might have shared his idea that rest is the natural state of any body. So in order to make the body move, there should be continuously force acting on it. So there should be a continuous supply of force. That is what is the idea of Aristotle. Later, the great Galileo Galilei has disproved this idea with an activity. We all know in 7th standard you have learned about Galileo's activity of pendulums. So he has made many, he did great activities with pendulum. So one of this activity from pendulum has has made him to think like this. So pendulum we all know. So when it is moved from its mean position to some extreme position, it starts oscillating between the two extreme positions. So in such a way that if we ignore the air friction or the viscous drag due to air, this motion keeps on repeating. So what is responsible for the oscillations of this pendulum? One thing is the gravitational force which is pulling it down. So at the extreme position it stops, and then it goes to the other extreme position. So this force which is acting on this side is like exactly balancing. So once the force is exactly equal and opposite, then immediately it starts moving in the opposite direction. Once again, with an increasing velocity, it comes down and it moves in the opposite direction till it experiences the same kind of gravitational pull. So on both the sides, it arises at the same level from its mean position. So that is what is Galileo's conclusion about or idea about simple pendulum. So the same idea he has applied to an imaginary movement of a marble. So he made an inclined plane. So for an inclined plane, his idea is on an inclined plane, if he leaves a marble and between this inclined plane, and he has placed another inclined plane making the same angle. So this marble rolls down with increasing velocity. So it rolls down with increasing velocity. Once it reaches the floor, it moves with constant velocity because there is no opposing force. Considering that the friction is less or ignoring the friction, it moves with the constant force, I mean constant velocity. So here initially there will be less velocity. So as it rolls down, because of the gravitational force, its velocity increases. It has maximum velocity here, so and moves. And as it rolls up the inclined plane on the opposite side, so it will move to the same distance, whatever height it is left from. So if I take this is the height from which this object is left. So on the other side of the inclined plane, it moves to the same height till it experiences an equal force in opposite direction. So then it stops and it come back. Now what he did is, if we this keeping the slope in the same way and maintaining the same height, if we keep the second plane in an angle which is less than the previous one, so when he does like this, so it comes here with maximum velocity and then it goes in the opposite direction till it experiences the same force in the opposite direction. So in order to experience the same force in opposite direction, it should climb to the same height. So it should climb to the same height means it is traveling more on this inclined plane, more distance on the inclined plane with less angle. Now if he has made this inclined plane still more slope, so keeping the first inclined plane the same height, making the same slope, but for the second inclined plane, if we decrease the slope to a greater extent, what happens now? This comes with greater velocity downwards and then has to move in the opposite direction till it acquires the same height. So it will travel still more longer distance as the inclination is decreased on the other side, because it experiences an opposite force in the opposite direction, like this direction. Now his idea is, if this object is, if on the other side, if we completely leave the inclination, like we don't make an inclined plane, instead if it is left horizontal, so then what happens to the marble which is rolling down? So the marble moves with greater velocity and it keeps on moving with the same velocity as we have ignored the friction till it encounters an opposite force. So it cannot encounter an opposite force because there is no inclination and no gravitational force acting on it. So from this idea he has given a law, like if a body, so his idea is that if a body is in uniform motion, it remains in uniform motion. If it is at rest, it remains at rest. So his idea is the exactly opposite of Aristotle concept. He said that there is no requirement, like there need not be an external force acting on an object. So even in the absence of external force, since we have seen the idea here, so once this object has reached the ground, there is no external force acting on this, and this marble keeps on moving with the same velocity even though there is no force acting on it. So if an object is moving with some velocity in a straight line, it keeps on moving with the same velocity in the same direction, so it does not require any force. That is what is the Galileo's idea. Now, expanding this idea, Newton has given his first law. So we call this first law as law of inertia too. So now we will discuss the Newton's first law of motion. So Newton's first law of motion. It is also called as law of inertia. Since we do not have much idea on inertia, so we will discuss it afterwards. So instead of writing the statement, I'll give the important tips, important lines from this. I'll pick up the important or the gist of this statement. Every body continues to remain in its state of rest. Every body continues to remain in its state of rest or of uniform motion in a straight line. Every body. If it is at rest, it will remain at rest. Or if it is in uniform motion, if it is in uniform motion along a straight line, it continues to remain in the same motion along the straight line unless an external force acts on it to change that state. Unless an external force acts on it to change that state. That is Newton's first law. So it is so simple. Whatever Galileo's idea, Newton has just shared the same idea in a statement form. Every body continues to remain in its state of rest or of uniform motion in a straight line unless compelled by an external force to change that state. Now, see, if a body is at rest, it remains at rest. If it is in uniform motion, it remains in uniform motion. So I can say that the inability of a body to change its state by itself, to change its state by itself. Have you understood the meaning of this? See, the body, if it is at rest, it remains at rest. It is unable to change its state. So the inability of the body to change its state by itself. If a body is in uniform motion, it continues to be in uniform motion, and its inability to change the speed or change the direction. So that inability of a body to change the state by itself is called inertia. Nothing but inertia. So if a body is unable to change the state by itself, you can simply call that as inertia. Or one thing, inertia can also be defined as it's an inherent property of any body. So it opposes. So because of which it opposes or resists. It opposes or resists any change in its state of rest or of uniform motion. In two ways we can define. Either it's an inability to change the state of a body by itself, or it can also be considered as like it if you are trying to make a body move, immediately you can't bring it to motion. Just like when you try to bring the bicycle to motion, initially you need to apply more force to make it move. Then once it is in motion, then continuously pedaling, with less effort it can move. So initially you require more amount of force. So that initial effort which we are putting, so that is something related to inertia, because it is unable to change its state, or you can say it is resisting the change which you are going to bring in its state of motion. So the greater the mass, the greater will be the inertia. Something like I can make the bicycle just move by pedaling. Now if a train engine has to move, then we can't pedal a train engine, or we can't push the train engine to move. So since the mass is more, it has greater inertia. That means its inability to change its state is greater, or it opposes greater change. That is why whenever brakes are applied to train, immediately it is not stopping. Like we don't stop the train immediately because of its greater inertia. So since its inertia is more, it stops after traveling certain distance. So it tries to remain in state of motion for a longer time. Then we have similar examples. So when we discuss about the types of inertia, we will learn these different types of inertias. Okay, inertia of motion, inertia of direction, inertia of rest. So we will discuss inertia of motion. Inertia of motion. So motion and inertia of rest, I will discuss them together. So inertia of rest. So you can observe this inertia of rest when you sit in a bus. So the first example I'll give is when you are sitting in a bus. So bus initially is at rest and you are also sitting on the bus. So if the bus starts suddenly, passengers will fall backward. So passengers fall backward. The reason why they fall backward is their lower part of the body is in contact with the bus and it moves along with the bus, but the upper part of the body tries to remain in state of rest. So it continues to remain in state of rest. As a result, the sudden change in state makes the body to fall backward. Second example, so one more is like the fruit, the ripened fruit, just like papaya. So if you shake the branches of a tree, this fruit is heavier and it remains at rest. So by the time the branches move, since it's remain in state of inertia of rest, it does not move along with the branches. So by the time it gets detached and it falls down. So it falls down. Inertia of rest, one more example I'll give. So when you play caroms, in the game of caroms, so the coins are put in pile like this. So coins are put on pile one on the other, one above the other. So when the striker hits the bottom coin, this bottom coin moves away and the rest of the pile remains undisturbed. So they are in state of inertia of rest. So by the time this body moves away and still the coins continue to remain in state of inertia of rest. Inertia of motion. So this example same like bus I can take. When bus applies brakes suddenly. So bus in motion, already in motion, if a sudden brake is applied, so then all the passengers fall forward. So all the passengers fall forward. Why they fall forward? The reason is they continue, their body continues to be in state of motion. But the lower part along with the bus comes to rest and the upper part continues in motion along with the bus. As a result, their upper part of the body fall forward. The second one is passengers while getting down. A running bus or a running train or running bus. So what happens? They need to run along with the train or a bus for some time. If they don't run, they fall forward because they were traveling or they were moving along with the bus or train for some time. So if the bus breaks, sorry, if the passenger has to get down, they will land on a floor which is at rest. So their body, since it is in inertia of motion, it continues to move, whereas their feet or foot touching the floor comes to rest suddenly. As a result, they cannot balance their weight and fall forward. Third example, I can give this one as the luggage which is kept on the bus is tied because they may fly away. One more, long jumpers. So athletes who are taking long jump, what they do, they run for some distance. So they run for some distance so that their body continues to be in motion for some time. And when they see this line, so this is the pit in which they are going to jump. So when they raise in air, because of inertia of motion, they continue to be moving in the air for some time and they reach to a distance where they are going to land in the pit. So this is because of inertia of motion. They can easily create a long jump. The greater their run, and I mean the velocity, and the lighter the body is, so their inertia, which we can say, is they can carry it for longer time. In this, particularly in this case, actually inertia depends on mass, but if they are heavier, then they fall easily down. Whereas the lighter case here, so if their body is lightweight and if the velocity is more, then they continue in the air for longer. So something like it is like a contradiction, but here we need to consider even the gravitational pull acting on the body when that body is in air. Okay, now inertia of direction. So we all experience this, that is, if a bus which is running in a straight line takes a sharp turn. So when the bus takes a sharp turn like this, all the passengers fall in opposite direction. So the passengers in the bus fall in this direction. The reason is, as long as the bus is moving in this direction, the passengers continue to, I mean, their body will be in the inertia of direction straight line. Now if the bus is taking a turn along this direction, so in order to retain in the same straight line, so the passengers will fall in the opposite direction. It is due to inertia of direction. Second case, you can see that, so for the tire, so you have, for vehicles, there will be a mud guard. So this is mud guard. Mud guard will prevent the mud from raising up. The reason is, so when the vehicle moves in mud, these mud particles stick and raise along with the tire. So when they stick along with the tire after raising some height, so due to their lightweight, or maybe chances are there that they just stick to the wheel for some time, and after that, because not exactly the lightweight, we can say that because of the gravitational pull only, actually they just stick to the tire for some time, and when the tire is in contact with the ground, they stick. When the tire raises up, they do not stick, they get detached. But since the tire is moving in this direction, so as the point, at the point where they get detached, they fly away tangentially. So when they fly away tangentially along this direction, so they may fall on others. So because of which the mud guards are provided. So you may experience this during rainy season when you are traveling behind a bike or something. You can see that the raindrops, or we can see from the road, not the raindrops, from the road, the water, which is the puddles of water which is there on the road when the vehicle moves, from the back tire it raises up tangentially in this direction. So these are some examples of inertia of direction. So the next concept we will discuss about the momentum before we go to Newton's second law. So one more important concept in this lesson is momentum. It is also called as linear momentum. The reason is we have angular momentum in rotational mechanics. So since we are studying motion along a straight line, it's linear momentum. So in linear momentum, how to understand this? So momentum is, according to definition, as per definition, it is the measure of quantity of motion possessed by a body. Something like quantity. It is the measure of quantity of motion possessed by a body. So when a body is moving, actually there are two important physical quantities or properties which are related to that body. So one is mass. Something like we have a table tennis ball, so TT ball, which flies and hits with velocity v, something like 40, not 40, okay, 80 meter per second. Since it is very lightweight, if it hits, nothing happens. But if a cricket ball which is moving with the same velocity 80 meter per second, sorry, 80 kilometer per hour, I'll write, meter per second is not correct, so generally we will have this in kilometer per hour. So 80 kilometer per hour, and this one is also moving at 80 kilometer per hour. If this hits, so this is a cricket ball, Which one you think creates more damage? Definitely the one which is having greater mass. So the one which is having greater mass creates greater impact. So the velocity, I mean here mass plays a key role. So greater the mass, greater will be the impact. Second one, so a bullet which is thrown from hand, like bullet mass is very less, so its mass is some in grams it will be like 5 to 10 grams between, or 50 grams max. Okay, this bullet, if it is thrown with hand, so you take a bullet and throw with hand onto a person. The second thing, if the same bullet is fired from a gun. Now if the same bullet which is inside the gun with the same mass, which is very less, so if the same bullet is, let me take it as 50 grams here and 50 grams here, so the mass is same. Now if it is fired from gun, now the impact of this, the impact created by this bullet is more. The reason is its velocity is very less and it has greater velocity. So velocity is very great. So two cases we have seen. The mass is greater, the impact is greater, the velocity is greater, the impact is greater. So momentum or linear momentum is a quantity which is also defined as, or we can say the mathematical equation of momentum, linear momentum, is the product of mass and velocity. It is represented with small p, and it's a vector quantity because velocity is a vector quantity. The direction of momentum is the same as the uh, the direction of velocity. And if we take the units for this, for mass we have kg, and for velocity it is meter per second. So SI unit of momentum is kg meter per second. This is about momentum. Newton's second law we can discuss. Meanwhile, I will stop this for now for verification purpose or internal purpose. Okay, thank you and namaste.